Hey everybody, welcome back aboard the Amiens. This is our second webinar in the series of 4, and we're going to talk today about navigation and the change in navigation from the 18th century to today. We're not navigating on this ship in the 18th century style, but I will tell you that the 3 essentials to navigation back then are still the 3 essentials that we have today. And that is knowing how fast you're going, what direction you're going in, and what time of day it is. Ships back then kept time in a very ineffective way from our standards, using an hourglass. And if you don't know what that looks like, I'd recommend that you look it up. It's kind of cool. Some of the times you've used them in games that you've played with. It basically looks like 2 pieces of glass stuck together with sand in it. And every half hour, it was someone's job to spin that around. That's how they kept time on a ship in the 18th century. And knowing which way you were going, you use something that's called a compass. And the compass tells you whether you're going east, west, south, the 4 cardinal points, or anywhere in between. The last piece of data that you need to have was how fast you were going. And they then used think of it as a long rope with a bunch of knots tied in it at equal lengths, and they would count how many ropes would slip through their hands in a certain amount of time. If you can imagine, they were counting time with an hourglass. There are a lot of imprecisions. As you'll see later, we've advanced a long way, but the same principles still apply. So stay tuned. So obviously the tools that they had 235 years ago and the tools we have today are very, very different, but they have the same purpose. The purpose is we need to know where we are so that we can know what direction to go in to get to where we want to get to. And we're going to go to Woody, who's one of the sailors aboard the Amiens. He was going to explain how we do things today.
Okay, so what I'm going to do is take the coordinates that we're at currently, which is given to us by satellite. And our coordinates are 32 degrees north, 7 minutes and 4 seconds. There we go. 10 degrees west. Good enough. 32.7 and 10 degrees. So we'll come over to the chart. Okay, and here we have our nautical chart. And on land we call these things maps, but at sea we call them a chart. But what we're going to do to plot the course is look at the marks on the side and the marks on the bottom. So the ones on the side, that tells us our north and south. And because we're in the northern hemisphere, as we look at the numbers, they go up towards the north and down towards the south. So we'll get our north direction, and that's 32, 30, 31, 32. And 7, and then we'll come right across, and you can see sort of where we've tracked where we've been, and we come down here to the bottom and we find 10 degrees, which happens to be this line here, and that's 10 degrees west. So that's pretty easy for us. We just have to plot this 7 there. We transfer it with the dividers. We'll make a mark, and then because we got our GPS, we'll put a circle around it and the time, which is 17:30, 5:30. If we were to plot with a visual representation, we would change the mark a little bit and we would make it a triangle. So we'd have a dot with a triangle over the top. But because GPS, we put a circle. Use paper charts because it's good to have redundancy, especially on these sailing ships. We don't know whether or not the GPS is going to fail, and sometimes if we don't zoom in enough, as we found out on the most recent Volvo Ocean race, that we can forget that some things will not show up on the GPS chart. The GPS chart changes when you zoom in and you zoom out. One important thing to remember with these charts is that because the Earth is round, we're projecting it onto a flat surface. And what happens is that things change slightly because of the geometry, but we don't need to get into the geometry. But what we do need to know is that if we take our mark down here at the bottom, let's say we take 10, and we transfer it all the way up here to the top, that 10 is slightly different. The 10 up here is smaller than the 10 down here. Okay, let's talk about currents. So in most places in the ocean, because of the rising and falling temperatures, it pulls the water around the sea. And when that happens, we have to take that into effect. Because we are just a sailing ship that is floating around the ocean, and if there was no wind, we would stay still, unless there's a current. And let's consider this little eraser here our ship, and we'll consider this this rule the currents of the ocean. And let's say the currents are flowing in circular pattern around this area, and it's coming in this direction. If we had no wind, we would be sitting there and floating around with the current. But if there was a wind coming across and hitting the ship and pushing us forward, the current would be coming sideways, which would bring us sideways as we go forward. So we have to take into account the currents and the winds whenever we're sailing a ship. Instead of ending up here, we end up here. So that's why we have the course over ground and also our heading on the chart, on the magnetic chart.
Okay, so the key thing to remember from what Woody just said was that the direction that the ship is going over the water is not necessarily the direction it is going over the land, because of the effect of the current, which we get from taking those GPS positions all along the way. We can see what it is. Back in the 18th century, they didn't have GPS, so they didn't know what the effect of the current was. They had another tool that they used. We're going to go to Antoine now, and we'll find out what that was. Antoine.
Yeah.
So, 200 years ago,
Yeah.
how did they know where they were?
Thanks to celestial observation.
Okay.
Thanks to the angle between the celestial object and the skyline. And second tool was the time, which was
Not so good.
not so good.
Yeah, they used that hourglass thing,
Yeah.
and there was a lot of error there.
Yeah.
So what Antoine is using is called a sextant, and it's a very useful tool in terms of giving us a position by measuring the angle between a celestial body of choice in the sky and the horizon. After a series of difficult calculations, we can then determine that we are somewhere on a line that encircles the globe. And because we've been keeping our dead reckoning, we've been keeping an idea of where we are. We know somewhere about where we are. But to really be precise, we have to then do the same calculation 2 or 3 times during an afternoon or an evening to get 3 lines that encircle the globe. And where those 3 lines intersect gives us our position. Overall, though, when we go back to the 18th century, the biggest problem they had was time. As we've said before, an hourglass is not a very precise measure of time, and until the chronometer gets invented and used on a boat, all of these fixes had huge errors. Antoine, thank you very much. That was incredible. It's obviously not simple, and I'm sure a lot of you who just listened to all of this have a ton of questions, and what I want to encourage everyone who's on this webinar today, if you've got a question, remember there's no such thing as a stupid one, so ask it, because the experts are online and they will answer them for you. Stay tuned for our next webinar. It's May 12th, same time, and it'll be about life aboard. So you'll learn a little bit about what people do on board, not only the work, but also how they have fun. So it's been a pleasure. Ben, take care of everybody, and we'll talk to you soon.